Good morning, everyone. I bring you greetings in the name of the Most High God. Um, this is Mass for you with Branco. It's been long while that we met here to discuss mathematics. This year we're going to do lots of questions, so you must follow me. If you are not a member, you can also attend to my classes in Tanzania, Trimax Education Center. This is where I work, and this is where I stay. So if you want to get contact session, just find your way to Trimax Education Center in Tanzania City, NU2, in MNK building. So you can find me there. Come and register and let me teach you one-on-one. So this is what we do. Sequence and series is grade 12 topic, but in grade 11 we do number patterns, and it's still relevant in your questions grade 12. So we'll be looking at quadratic number pattern from grade 11 as a recap to introduce the new concept, which is sequence and series. So most of the times we use the formula Tn is equals to an squared. You can see an squared plus bn plus c, but we don't know how these formulas came about. So I took my time to unpack it so that you understand that when you are using the formula where it came from. So we say how to find a, b, and c. So we started with term 1, t1, and we say t1 is the same as a into bracket 1 squared plus b into bracket 1 plus c, and then it gives us t1 to be a plus b plus c. Okay, and then t2 is equals to a into bracket 2 squared plus b times 2 plus c, which also gives us 4a plus 2b plus c. That is term 2. Term 3, you always substitute the 3, which is the position of the term, and then we say a into bracket 3 squared plus 3 times b plus c, which also gives us 9 plus 3b plus c. That is term 3. From there, I arrange it as sequence. Term 1, term 2, term 3. So it's 9a slash, so here is term 3. You can see there. So as we move forward, we have a plus b plus c as term 1, 4a plus 2b plus c as term 2, 9a plus 3b plus c as term 3. And when you pair it, it's t2 minus t1, t3 minus t2. It's a quadratic number pattern, so the first differences represent a linear pattern. It represents what? A linear pattern. So now when you subtract 4a minus a, it gives me 3a. 2b minus b, it gives me 1b. c minus c goes away. That is T2 minus T1. Similarly, if I do the same thing for T3 minus T2, 9A minus 4A give me 5A, 3B minus 2B give me B, C minus C gives me nothing. So it goes away. Now I have 3A plus B as the first difference and 5A plus B also as the first difference. So I pair it again, and now it becomes T2 minus T1 because there are only two terms we are seeing there. What is 5a minus 3a? It gives us 2a. b minus b goes away. So this is where this formula of 2a, when we are calculating a, we use 2a equals to whatever number that is in this position. Whenever we are calculating b, we use 3a plus b. After we know a, we substitute here and we find b equals to whatever number that is in this position. When we want to find c, we use the a from here, b from here, and add it to c and place it to be equals to the first number in the quadratic number pattern. Then we find our values of a and b and c. Then from there we substitute into the formula an squared plus bn plus c. So we're going to take a look at this question from November 2020. I'm going to only focus on the quadratic number pattern. It says given the quadratic number pattern minus 3, 6, 27, and 60. And they say determine the general term of the pattern in the form Tn equals to an squared plus bn plus c, and that was 4 marks. 2.2.2, calculate the value of the 50th term of the pattern. And then 2.2.3 show that the sum of the first n terms, show that the sum of the first differences of this pattern can be given as Sn equals to 6n squared plus 3n. And the next question says that how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060 4 marks. So we're going to look at this question properly now and find solutions. So let's get to work now. So now we're going to work the question out as we have been told to do so. We will consider question number 2.2.1, which says we must, given the quadratic number pattern is minus 3, 6, 27, 60 in this order. So you first find the first difference. And so when you find the first difference, you will come into realization that 6 minus 3 is 6 plus 3, which is 9. 27 minus 6 is 21. 60 minus 27 is 33, like that. So there's no difference here. So let's check the second difference here like this. 21 minus 9 is 12. 33 minus 21 is also 12. So you see, a quadratic number pattern is a pattern with a second constant difference. It's a second what? Constant difference. So here we get constant difference in the second difference. But in the first difference, there wasn't any constant difference. So it gives us a linear pattern also as well. So the difference of a quadratic number pattern is always a linear pattern. It's another pattern on its own. So now, like what we said, now we want to find A, B, and C. Remember, we have just dealt with how to get it. So we said 2A is equals to which number? This number here. That's where we saw the position 2A. So you put your 12, start solving from bottom to up in this order. Okay. So 2A is equals to 12, divide here by 2, here by 2. Therefore, A is equals to 6. That's it. So we get 6 as our A. Okay. Now the next step will be 3A plus B equals to that number, because that was the position we proved the 3A plus B to be. So we have 3A plus B is equals to which number? 9. What is our A? Our A is 6. So open bracket, put 6. Put your B equals to 9. 3 6 is 18 plus B equals to 9. We are solving for B. So what do? We transpose this 18 to this side, and therefore our B is equals to 9 minus 18, which is minus 9. That is the value of our B. Okay. Now we want C. So what did we say here? We say here must be A plus B plus C, and is equals to always the first term. What was our first term? Minus 3. So we go and use A plus B plus C is equals to T1. T1 is equals to minus 3. Remember from the proof how we got it. So our A is 6, our B is minus 9, plus C equals to minus 3. So when you check 6 minus 9, give us minus 3 plus C equals to minus 3. So in this case, what do we have here? We are given this, so to solve for C, just transpose this minus 3 on the left to the right. Is moving with the negative sign, so it changes to become positive. So minus 3 plus 3 gives you 0. So now in this case, we say therefore our Tn is equals to an squared plus bn plus c. Therefore, let's substitute. Tn is equals to a is what? 6n squared. What is our b? Minus 9n. What is our c? Is 0. So you can choose to ignore the 0. And that's how you get to your formula. So the formula for the quadratic number pattern will be this here.